Students, all of you, good evening. Welcome to the session. Continuation of circuit theory, that is network theory concepts. I'm discussing chapter 1, that is fundamentals of electrical circuits. I'm starting lecture 17 on fundamentals. In this session, mainly how to see some practice questions with respect to fundamentals of electrical circuits. Before starting the different models of questions, I already given with respect to fundamentals different concepts, and for each concepts I solve different models of questions also. Now I'm going to starting to solve the different models of questions with respect to fundamentals by covering all the concepts. Before that, first we'll have to see the what you mean by effective resistance. In sometimes in the competitive exams, the questions are asking calculate effective resistance or calculate input resistance like that. How to define the effective resistance or input resistance? The effective resistance is the resistance offered by the network. This is the resistance, that is total resistance offered by the network to source under the network condition. How much resistance is offered by the circuit to the source? That is nothing but effective resistance. But here you have to calculate in two methods. If the circuit is in passive nature, means there is no any active element. There is no any active element if the circuit in passive nature. Then the effective resistance is equal to Thevenin's equivalent resistance. Whatever the effective resistance we are calculating, that is equivalent to Thevenin's equivalent resistance. What is the Thevenin's equivalent resistance? Later we'll see theorems. If it is a purely passive network means there is no active element. But point to remember, students, if any network consists of dependent source without any independent source, then that network totally is a passive network. Even though dependent source is present, if there is no any active element, then it is a passive network only. Even though dependent source is present without any independent source. If network is purely passive, then effective resistance is equal to Thevenin's resistance. If network has active element, effective resistance calculation is different. If it is an active element, if it is consist of independent source like that, then in that case, the effective resistance calculation or input resistance calculation is different. If, for example, if the question is asked like this, you have to calculate what is RAB. Just by seeing the circuit, there is no any independent source. Means no active element here. Dependent source and resistive, then this is equivalent to passive circuit only. It is a passive circuit. Even though dependent source is present, there is no independent source now. That's the reason it is a passive circuit only. In this case, RAB, that is equivalent resistance between A and B terminals, is equivalent to Thevenin's equivalent resistance. Even in the explanation of Thevenin's theorem, Norton's theorem also, I will explain this concept later on. But point to remember, students, in this case, to calculate the resistance, equivalent resistance or effective resistance or Thevenin's equivalent resistance, if only dependent source is present, there is no any independent sources. Let's assume that at input terminals, we have to assume that this is one method. Here I am assuming that 1 ampere current source. Let I am connecting the 1 ampere current source. Once we can connect 1 ampere current source, for this case, the input voltage is Vx. The input voltage is Vx. Current we are assuming that 1 ampere current source. Then how to calculate RAB? Is RAB equal to Vx by 1 ampere. Is Vx by 1 ampere gives the RAB. Then how to calculate the Vx? Then to calculate Vx, apply KVL in this loop. How much current we are allowing? This is the method you have to apply. If only dependent source is present, there is no any independent source. Then connect based on our, that is based on the given condition. Sometimes you have to connect the voltage source, sometimes you have to connect the current source based on the given circuit one. But here current source is required. That's why I'm connecting the current source. Then 1 ampere current is flowing here, plus minus 1 volt to drop. Here plus minus 2 into 1 ampere, 2 volts to drop. Then this is Vx by 2. This plus minus 3 volts to drop. Then apply KVL in this loop. How to calculate the RAB? I'm explaining here. Apply KVL. Then if you apply KVL, positive to negative, negative, minus 1, positive to negative, negative, minus 2, positive to negative, minus Vx by 2, positive to negative, minus 3, this negative to positive, that is plus Vx. Plus Vx equal to 0. From this, minus 1, minus 2, minus 3, minus 6, minus 6, this is minus Vx by 2, this is plus Vx. This is plus Vx by 2 is equal to 0. From this, what is Vx equal to? Vx by 2 equal to 6. Then Vx equal to 12 volts. Then how to calculate RAB? Is RAB equal to, that is Vx by 1 ampere. This is 12 volts by 1 ampere. This is equal to 12 volts. The effective resistance between A and B terminals. that is equal to RAB. This is equal to 12 ohms. That is the final answer. The effective resistance RAB, that is equal to 12 ohms. That is, which option is correct? This option B is the right answer. Like this, you have to proceed. Clear? Let us assume that 1 ampere current source is connected with this process only. That is, with this method only, how to solve that. This is a previous gate question. Can anybody answer this? The impedance looking into nodes 1 and 2 in the given circuit is. You have to find what the resistance or impedance looking into the nodes 1 and 2. Find the what is the impedance looking at nodes 1. Let assume that between 1 and 2 terminals we are connected 1 volt source. We are connected 1 volt source. Then if you have to find what is the resistance between 1 and 2 terminals, that is effective resistance, is 1 and 2. Here also there is no any independent source, active element. Only dependent source is present. The method you have to apply. Let assume that here voltage is, I am assuming that 1 volt. This is 1 volt. Then you have to find R1. Then R12 equal to V1. That is 1 volt by the total current IT. The total current IT students. Yes. Then how to calculate the IT current? The total current IT, how we can calculate. Then apply KCL at a node. Apply KCL at this node. How to calculate the total current at this node. KCL you have to apply. Then this current is entering and this current is leaving and this current is also leaving. This current is also leaving. But this IB direction is given like this. Then if you apply what is the total current IT equal to? IT equal to. Here 1 volts means what is the voltage at this node is also 1 volt. Voltage at this node is 1 volt. 1 by this total resistance. 1 by this 1 kilo ohm plus 9 kilo ohm, that is 10 kilo. 1 by 10 kilo. Correct? 1 by 10 kilo plus this voltage is 1 volt. I am calculating current 1 by 100 volts. 1 by 100 volts plus this current is leaving, but this current is entering. I am taking entering current as a negative. Entering current as a negative. That is minus 99 I. This is the total current. The total current at this node I am calculating 1 by 10 kilo ohms. 1 by, or you have to apply nodal analysis at this node. Nodal analysis means we are calculating the currents. This current is leaving, this current is leaving, this current is entering. This total current equal to 1 by 10 kilo ohm is 1 by 100 minus 99 I. But what is IB? Yes, friends. This IB and these currents are opposite now. This IB and these currents are opposite. This is what is this current? 1 by 10 kilo ohm. 1 by 10k. Instead of 10 kilo ohm, if you write 1 by 10k. 1 by 10k. Simply you can write 1 by 10. And this current is opposite now. I am substituting like this. This is 1 by 100 plus 1 by 10k. 1 by 10k. This minus 99. But IB is this IB is opposite to this one. That's why I taking minus 1 by 10. Shall I write like this? 1 by 100 plus 1 by 10k. This minus into minus plus. That is 99 by 10k. 99 by 10k. Then you have to simplify this. IT equal to 1 by 100 plus this is 100 by 10k. 100 by 10k. 100 by 10k. Is it correct? Then if you simplify this, 1 by 100 plus 100 by 10 into 10 cube. K is kilo, 10 cube. This 1 by 100 plus, by simplifying this 1 by 100 again. Then what is IT equals, friends? 2 by 100. Then how we can calculate R12, the resistance between 1 and 2 terminals? 1 by IT. Then this IT, 1 by, what is IT? 2 by 100. That is 100 by 2. This 100 by 2 equal to 50 ohms. Then resistance between 2 terminals is 50 ohms. This is a 2 marks question in GATE exam. Clear? Assume that 1 volt. Now you have to calculate the total current. The total current, this current is entering and these two currents are leaving. This is the total current driven by the source. IT is the total current driven by the source. That you have to write. If you want still any doubt, according to KCL, some of the entering currents equal to some of the leaving currents. Actually, this is entering a minus IT. You bring this side, then this becomes IT. That's the only reason. Clear, students? This is according to KCL only. I written this is IT. This current is IT. This IT current is AC. Then I got this is equal to 2 by 100. To substitute here, we are getting 50. That is option A is the right answer. Clear? Any doubt? Yes. Can anybody answer this question? Determine current I. This is also a gate question. Determine I current. This I. Yes, friends. How to find the I value? First, I am calculating equivalent resistance. This 5 ohms and 9 ohms is series. This is 14. This 14 in parallel with 14. The 14 in parallel with 14. This comes 7 ohms. This equivalent comes 7 ohms. 7 ohms, 11 ohms, 18 ohms. 18 ohms. See this one. This 18 ohms is parallel. This 18 ohms, 18 ohms is parallel. Understood? Understand, students? This is 9 ohms. This 9 ohms, 13 ohms, 22 ohms. 22 ohms, 22 ohms parallel. Then how much you can get? This total, how much you can get, sir? 22 ohms, 22 ohms parallel. 11 ohms. 44 volts, 11 ohms. That is 44 by 11. This is equal to how much? 4 amperes. The input current is 4 amperes. Understand? Any doubt? The input current I got 4 amperes. That is 44 by 11. This is equal to 4 amperes. Once again, I am explaining. 9 plus 5, 14. 14, 14 parallel. 14, 14 parallel. 7. 7 plus 11, 18. 18, 18 parallel. 9. 9 plus 13, 22. 22, 22 parallel. 11. The equivalent resistance equal to 11 ohms. Then what is the R equivalent you can get? R equivalent equal to 11 ohms. Voltage is 40 volts. 44 volts. Then what is the current? Input current. Not this current. I am talking about input current. The current at input side is 44 by 11. This is equal to 4 amperes. Now, you have to calculate what is the I current. Up to this, okay, 4 amperes of current. The input current is how much, friends? This is equal to 4 amperes of current. This is not the answer. Now, you have to calculate what is the I in this branch. Once again, listen please, how to calculate that I. It's very simple. See, to calculate this, see how to calculate. Up to now, I explained how you are getting that 4 amperes of current. It's very simple. Up to this, it is a 4 amperes. Now, what is the current through these branches? It's very simple. But don't think like this. The current is divided between only these two resistances. The current is divided between this branch. And this current not only depends on 13 ohm resistance. This current is also depends on all these resistance values. Very important, sir. Mostly students will think like this. Most of the students, because current is entering here, that's why it is divided between these 13, 22 and 30. 20. This is positive and this is negative. Negative is connected here. No? That's why this current is dividing this 22 ohms and 13 ohms, and this 13 ohms is connected with all these resistances. I already calculated. What is this equivalent resistance, friends? Can anybody? What is this equivalent resistance? Up to now you calculated now already. This total how much you got previously? How much you got, sir? 22 ohms. 9 plus 5, 14, 14, 14 parallel, 7, 7 plus 11, 18, 18, 18 parallel, 9, 9 plus 13, 22 calculate. That means this 4 ampere is dividing 22 ohms and this total is also 22 ohms. This total is also 22 ohms. Now it is 22 ohms to 20, that is 22 ohms, 22 ohms it is dividing now. That's why equal resistance dividing means it is 2 amperes, it is also 2 amperes. Now, come on friends. This is 2 amperes. This current division 18, not only 11, this 11 is connected. All these resistances. All this it depends. But up to now, what are the resistance we calculated? 9 plus 5, 14. 14 plus 14, 14. Parallel. 7. This 7 plus 11, 18. That is, this is 18. This total resistance is also 18. This total resistance is also 18. Here up to now, it is a 2 amperes. Now, what is this current? 1 ampere. What is current? 1 ampere. Now, this 1 ampere is dividing again. This is 14. 9 plus 5, 14. Equally dividing now. Equal resistance now. That's why it is 1 by 2 amperes. This is also 1 by 2 amperes. Now, what are the current, students? Therefore, the current I equal to 1 by 2 amperes. It's very simple now. Answer is 1 by 2 amperes. Any doubt? Very good conceptual question. It's very easy question, but good conceptual question. How to consider the resistances? This I got I equal to 1. I is not 4 amperes, students. In this branch, the current equal to 1 by 2 amperes. Clear? Up to this, the current is how much you got? 1 ampere. This I is dividing. Equally, why equal resistance? That's why equally divided. 1 by 2, 1 by 2. That is 1 by 2 amperes. Clear, sir? Please concentrate. Can anybody answer this question? This is also previous gate question. If VA minus VB equals 6 volts, then VC minus VD is dash. If VA minus VB equal to 6 volts, then VC minus VD is dash. This is also very simple. They given the statement. What they given? If VA minus VB equal to 6 volts, VA minus VB equal to 6 volts. That is, voltage across this one is 6 volts they given. Once you know this 6 volts, what is this current? 6 by 2. This is equal to 3 amperes. Correct? They given voltage now between A and B. 3 amperes. Once it is 3 amperes, 3 ampere is entering here. 3 ampere is entering. This is 3 amperes. This is 3 amperes. If 3 ampere is entering means this is one network now. Please concentrate. This is one network now. This is one network. A circuit. This is one circuit. What is the entering current for this network? 3 amperes. Then finally, total this will distribute. Finally, the current is leaving is also 3 amperes. For this network, whatever the current is entering, same current is leaving now. If you want, divide this one and finally calculate this, you can get 3 amperes on. Clear, sir? This is 3 amperes. Entering current 3 amperes, leaving current is also 3 amperes. But you have to calculate VC minus V. Now concentrate. At this node, what is the current entering? 2 ampere. What is the current entering? 3 ampere. What is the current leaving at this node? 5 ampere. The current is entering, the current passing through 1 ohm resistor is 5 ampere. 5 into 1 ohm, 5 volts. This is 5 volts. 5 into 1 ohm, 5 volts. Wherever the current is entering, that is plus, and this is the minus, 5 volts. But you have to calculate VC minus VD. VC minus VD. VC minus VD. That is voltage between these two are parallel branches now. This is minus, this is plus. How much you got? 5 volts. But VC minus VD, negative. VC minus VD. This is minus plus. That's why VC minus VD means, say for example, let this is VC, positive, negative VC. This is grounded. If you want this clearly, this plus 5 volts or minus 5 volts. And just by seeing that one, we are defining C to D, but it is minus plus. That's why minus 5 volts. Still any doubt? This is VD. Then apply KVL in this loop. Apply KVL. Because these two are parallel, sir. This is minus plus 5 volts means this is also minus plus 5 volts. Negative to positive, positive, VC. Negative to positive, positive, plus 5. Positive to negative, negative, minus VD equal to 0. VC minus VD equal to minus 5 volts. Actually, no need to do KVL here. We are defining C to D, but it is minus now. That's why minus 5 volts. Is it minus 5 volts? Then VC minus VD equal to minus 5 volts. Clear? If VA minus VB equal to 6 volts, what is VC minus VD? Here, no need of any confusion here, sir. This is one network. What is the current entering this network? 3 amperes. The leaving also 3 amperes. Whatever the current is entering to the network, that same current will leave. And here, no need of any confusion. 3 ampere is entering, 2 ampere is entering. Leaving current is 5 ampere. 5 ampere is entering at 1 ohm resistor. Drop is 5 volts. Minus plus 5 volts. But you want C to D now. C to D minus now. That's why minus 5 volts. VC minus VD equal to minus 5 volts. That is option A is the right answer. This is also gate mode. This is also previous gate questions. Yes. Can anybody answer? Determine the effective resistance seen by the voltage source. Here, previously you calculated effective resistance. These cases, there is no any independent source, no active element. But here the problem, here active element is present. If active element is present, how to calculate the effective resistance? How to calculate the effective resistance? R effective equal to this current, let this current is I, V by I. Already voltage is there, current you can calculate, R effective equal to V by I. Then how to calculate the current source? Come on. This is very simple. These two are parallel branches now. What is the voltage across this branch? 18 volts. What is the voltage across this branch is also 18 volts. 18 by 6, 3 amperes. 18 by 3, 6 amperes. This is how much? 9 amperes. It's already 9 amperes. Then this total current is entering current equals sum of the leaving current. 3 plus 6, 9, 9 plus 9, 18. 18 volts by 18 amperes. How much? It's 1 ohm. Option A is the right answer. Simple. 18 volts by 18 amperes, that equal to 1. Clear, friends? Yes. Can anybody do this problem? All are conceptual questions. Simple once you know the concept. Can anybody try next question? Can you calculate what is I1, I2, and I3? Come on, do it. Come on, sir. What is the answer? What is I1? What is I2? It's a very simple question. Yes. Concentrate. Here, this current is 12 milliampere. It is they given 12 milliampere. This 9 milliampere. At this node, 12 milliampere is entering, 9 milliampere is leaving, and this current is also leaving. How much? 3 milliampere. That's why I1 equal to 3 milliampere. One is over. Next, what about I2? Listen, sir. Here, 9 milliampere is entering, 10 milliampere is leaving. Then what about I2? This 1 milliampere is entering. Then only 10 milliampere. This is 9. This is 1 entering. 9, 1 is entering, 10 is leaving. Then I2, what is I2? Minus 1 milliampere. Opposite now. This 1 milliampere opposite I2, minus 1. Next. This is 10 milliampere is entering, 12 milliampere is leaving. Then what about this current? 10 is entering, 12 is leaving, means 2 milliampere must be entering. Then what is I3? I3 equal to 2 milliamperes. That's answer. Correct? I1 is 3 milliampere, I2 is minus 1 milliampere. Just KCL. I3 equal to 2 milliampere. I3 equal to 2 milliampere. All are conceptual questions. Can anybody answer this? Once you are strong in fundamentals, theorems are very easy. AC analysis separate concept. Transitions also separate concept. And two-port networks, that is to solve the two-port network question, fundamentals are required. And the next one is resonance, formula based only. Coupled circuits also formula based only. Maximum transitions concepts, fundamental concepts is somewhat more preparation is required. Remaining is very easy. Transitions and these fundamentals, more preparation is required. That's why taking more hours on fundamentals. Remaining is easy. Can you find Ix, Iy, and Iz? Say in KCL alone. What is Ix value? Common students. What is Iy value? What is Iz value? Come on, wait. Yeah. Listen, sir. This 10 ampere is entering, 8 ampere is leaving, 2 amperes also leaving. 10 ampere is entering, 8 ampere is leaving, 2 ampere is leaving. Then Iy equal to 2 amperes. Oh, Iy equal to. Now, see, 2 ampere is entering, 10 ampere is leaving. This 2 amperes is also entering. This is 10 ampere is leaving, 2 ampere is entering, 2 ampere is entering, means how much current must be entered? 6 ampere must be entered. Sum of the entering current for sum of them. Then this direction and this direction is opposite. Then Ix equal to minus 6 amperes. What about Iz? 8 ampere is entering, 5 ampere is also entering, then 13 ampere is leaving. Then Iz equal to 13 amperes. Over. Next. Can you try this? Calculate V1, V2, and V. This is the KVL based question. Simply you can apply the KVL. Yes, friends. For example, if you apply KVL in this way, negative to positive, positive, 10. Positive to negative, negative, minus 5. Positive to negative, negative, minus 20. Positive to negative, negative, minus 3 equal to 0. 10 minus 25 minus 15 minus V1 equals. Then V1 equal to minus 15 volts. V1 equal to minus 15. Okay. How to calculate V2? Then apply KVL in this loop. Any direction you take, no problem. Positive to negative, negative. Negative to positive, positive. Negative to positive, positive. Then V2 minus 30 equal to 0. V2 equal to 30 volts. V1 equal to minus 15 volts. V2 equal to 30 volts. Is okay. Next. Apply KVL in this loop. Any direction you take. Positive to negative, negative, minus V. Positive to negative, negative, minus V. Negative to positive, positive, plus V equal to 0. What is V2 calculated? V2 is 30 volts. That is minus 30. V2 is 30. V3 how to calculate? What is V1? Minus 15 equal to 0. Then what is V3 equal to minus 45 volts? V3 equal to minus 40. That is the answer. V3 equal to minus 40 volts. Clear? Just KVL. These two problems are KCL based problems. Can anybody do this? Calculate Vx, comma, calculate Vx. Yes, for example, let us assume that the current is I. Apply KVL. So it's positive to the current, wherever the current is entering, positive. That is minus 7i plus 5. This is positive, negative. Minus 8i minus 50 plus 10 equal to 0. 7i, 8i, 15i minus 15i. 15 minus 50 minus 35 equal to 0. Then what is I equal to? 15 I equal to. From this you calculate the what is I squares. 15 minus 7i, that is plus 5 minus 8i, positive to negative, negative, that is minus 50 plus 10, minus 7i minus 8i minus 15i, correct? 5 plus 10, 15. If you take like this is, sorry, according to this one, this is plus minus if you take, because if you want to get the answer, maybe the sign is different. So this is plus minus, please correct it. This is plus minus. To do this, what you can get? Minus 5. Now simplify this. This is minus 45. Minus 45. Then what is I? I equal to minus 3 amperes. I equal to minus 3 amperes. If I equal to minus 3 amperes, now what is the voltage across this 8 ohms, friends? What is the voltage across this 8 ohms? This is, it's minus 3 amperes means voltage across 8 ohms is minus 24 ohms. Opposite to this polarity. Minus 24 ohms. Now you have to calculate Vx. If you try to apply the KVL in this loop, if you apply the KVL in this loop, apply KVL. Minus 20, negative to positive, positive, 24, positive to negative, negative, minus 50, negative to positive, positive, plus Vx equal to 0. Minus 26 plus Vx equal to 0. Then Vx equal to minus 26. Sorry, Vx equal to 26 volts. That is the answer. Because current is minus 3 amperes now. Minus 3 amperes means 8 into minus 3, minus 24. Minus 24 means opposite to this polarity. Then minus plus. Now apply KVL. Negative to positive, positive, 24. Positive to negative, minus 50. Negative to positive, Vx equal to 0. Vx equal to 26 volts. Any doubt? I got the current is minus 3 amperes, sir. This voltage drop, if you want, 8 into minus 3, minus 24. Minus 24 is opposite to this polarity. That's why minus plus I take. Now KVL you have to apply for this. Then I got a Vx equal to 26 volts. Next. Can anybody answer this question? I'm expecting answer from you. What is the current I? If more number of resistances are in parallel, how to apply current division rule? I told. N number of resistors are connected in parallel. N number of resistors. This is 33 milliampere means here also 33 milliamperes. If you want current I, this I equal to current through 2 kilo ohm resistor. If you have to calculate current through 2 kilo ohm resistor, total current into 1 by that resistance. 1 by 2 by 1 by 1 plus 1 by 2 plus 1 by 3. 1 by 1 plus 1 by 2 plus 1 by 3. Now, how to simplify this? 33 into, in current division rule for parallel connection, current division rule with more number of resistors. That current into that resistance by into 1 by 2 by 1 by 1, 1 by 2, 1 by 3 into 1 by 2. This is 6 is the LCM. 6 plus 2 3s, 3 into 1. 3 plus 3 2s, 2 1s. Then what is I equal to? 33 by 2 into 6 by 9, 11. How much you got? 11 ones, 11 threes, 2 ones, 2 threes. 9 million. I equal to 9 million. Very simple, sir. If more number of parallel, current division rule. If two resistors are there, you take opposite resistors. If more number of resistors are there, simply you can do like this. That current, if you want, total current into that resistance, you take 1 by 2 of that resistance. By 1 by R1 plus 1 by R2 plus 1 by R3. Please go through the how to apply current division rule. I given the formulas. Please go through that. Then 9 milliamperes is the right answer. I am expecting answer from you. In this circuit, what is I, what is V? Come on, students, do it. Can anybody tell what is I? Come on, sir. This is short circuit now. This is short circuit. Once it is short circuit, there is no current in this resistance. This is completely open. Then the current is flowing here. It is short circuited, current will flow like this. There is no current. There is no current means it is open circuit. Once it is open circuit, there is no current here. Then current is flowing here. 20 volts, 2 ohms. 20 by 2. 20. But here also no current. Here also current is 0. Here also current is 0. The total current will circulate here. Clear? Now tell. This 20 by 2. What is current, friends? This current 20 by 2 is equal to 10 amperes. The current equal to how much? Sorry, here 3 ohm resistor is there. No? Okay, this you have to take. There is one more resistor is there. Please take it. Adding this. Actually, this is good. This is missing in the problem. This is 3 ohms. This 20 by 5 ohms. The current will be circulated. This 20 by 5 ohms. This 20 by 5. It is a 4 amperes. The current is 4 amperes. Current is 4 amperes. Now, current equal to 4 amperes. What is the voltage? Can anybody? What is the voltage? The 4 amperes of current is flowing here. There is no voltage drop here. There is no any voltage drop. There is no voltage drop here. This 4 into 2, 8 volts. 4 into 2, 8 volts. 4 amperes of current is flowing now. 4 into 2, 8 volts. Plus minus 8 volts. This positive is connected here. The same negative is connected here. This is 8 volts. Then V equal to 8 volts. Here there is no current in this resistance. There is no drop. There is no current in this resistance. No drop. There is also no drop because of open circuit. But in open circuit, voltage is exists now. Plus minus. This voltage equal to this voltage. This voltage equal to this voltage. Here there is no drop. If you want KVL, you have to apply. You can get 8 volts. Clear? The current equal to 4 amperes and voltage equal to 8 volts. Okay. Can you check this question? Check your knowledge. Try to answer the question, students. What is the V? What is the I in this side? Come on, do it. What is V and what is I? Anybody? Okay. Yes, students. What is the current in this resistance? 1 ampere. What is voltage? 2 volts. These two are parallel. Na? This also 2 volts. These two are parallel. Na? This also 2 volts. If it is 2 volts, what is the current here? 2 by 1. The current in this is 2 by 1. 2 amperes. Here 2 amperes, this is 1 ampere. This is 3 amperes. This current is 3 ampere. This current is 4 amperes. 4 amperes. Okay. Then what is total current? 7 amperes. I equal to 7 amperes. Current is entering here, plus minus 32 volts. This also 32 volts. These two are parallel. V equal to 32 volts. I equal to 7 amperes. That is answer. Simple question. V equal to 32. I equal to 7. Then if you want to apply KVL in this loop, we can get V equal to 32 volts. Check it. Try to apply KVL. Apply KVL in this loop. We can get that. Because this is I is 7 ampere is entering, 4 ampere is leaving, 3 ampere here. Plus minus 12 volts. Plus minus 18 volts. 12 plus 18, 30. 30 plus 2, 32. Then also we can get 32 volts. You apply KVL in this loop, friends, then also we can get 32 volts. Clear? Like this you have the process. Can you try this one? What is V naught? What is R? All these are the previous gate and ESC questions. Whatever the questions I am solving, this previous gate ESC models. Anybody? What is V naught? V naught is here. Sir. This is V. This is given. What is V naught? What is R? What the voltage here? Tell me. The current is 2 by 3 ampere, sir. What the voltage here? 12 by 3. This current into this resistance. 2 by 3 into 6. 12 by 3. 4 volts. Then what is this voltage? What is voltage? Apply KVL here. Minus V16 minus 4 plus 20 equal to 0. What is V16? 16 volts. This is 16 volts. This is 16 volts, 16 ohms. What the current? 1 ampere. This 1 ampere entering is 1 ampere. 2 by 3 is leaving. Then what about this current? 1 by 3. 2 by 3 plus 1 by 3, 1. That is 1 by 3. The resistance, this is 1 by 3 ampere. This current is 1 by 3 ampere. This is 4 volts, means this also 4 volts. Why? These two are parallel. Then V naught is 4 volts. Voltage across the resistance is 4 volts, current is 1 by 3 amperes. What is R equal to? V naught by 1 by 3. V naught is 4. That is 1 by 3. 12 ohms. The resistance equal 12 ohms over. See how we can apply this KVL, KCLs. Yes. Can anybody answer this? What is the power delivered by dependent source? What is the power delivered by dependent? See, just simple circuits, but conceptual questions all this. Power delivered by dependent source. Apply KVL in this loop. Try to calculate I naught. Positive, negative current is entering. Minus 2 I naught. Positive, negative, negative. Minus 3 I naught. Negative to positive plus 10 equal to 0. Minus 5 I naught plus 10 equal to 0. Then I naught equal to 10 by 5. That is 2 amperes. I naught is 2 amperes. Then what is the power delivered by dependent source? What is the power delivered by dependent source? This current is 2 amperes. What is this voltage? 3 into 2, 6 amperes. So 6 volts. I naught you calculate 3 into I naught, 6 volts. But what is the power delivered? Delivered by dependent source. Here power delivered means actually if you take like this friends, plus minus, if the current direction is like this, positive leaving, then it is delivering the power. It acts as a source. But here current is entering at positive. Current is entering at a positive. Then it acts as a sink, not a source. Sink. Then this is minus. I'm taking, if it is current is leaving at positive, Then you take delivering the power, positive take. But here I am taking a minus because current is entering at positive. Positive to negative, take minus. This is 6 into, voltage is 6 volts, current is 2 amperes. 6 into 2. This is equal to minus 12 watt, not plus 12 watt, minus 12 watt. Sorry, minus 12 watts is the right answer. It is a sink, not a source here. If current is like this is V, then power equal to V into I. If the current is like this is I, P equal to minus VI. Current is entering at positive. Then which answer is correct? It's a minus. It's a sink. Then power delivered by dependent source is minus 12. Next. Can anybody answer this? What is V naught? Come on, do it. So many questions are there, sir. You take the gate instrumentation, previous questions. You take the gate electrical, previous questions. ESC electrical, previous questions. ESC, ECE electrical questions. Gate ECE, previous questions. So many questions. To try to complete that questions, you can get more confidence in the network. I'm asking what is V naught? There is 1 ohm resistance is also given. Sorry, some resistance value missing here. This is 1 ohm resistance. What is V naught? Yes. What is the voltage across 2 ohm resistor? V naught. Resistance is 2 ohms. Voltage is V naught. Then what the current here? V naught by 2. V naught by 2. Voltage is V naught. Current resistance is V naught by 2. Resistance. Now apply KVL. Positive to negative. Negative. Minus V naught by 2. Current is V naught by 2. Resistance is 2. Positive to negative. Minus V naught by 2. This is plus. This is minus. How much current is flowing? V naught by 2 current is flowing in the circuit. Positive to negative. Negative. 1 into V naught by 2. Negative to positive. Positive. Plus 20 equal to 0. This 2 cancel. Minus V naught. Minus V naught by 2. Minus V naught by 2. Plus 20 equal to 0. This is minus 2 V naught plus 20 equal to 0. Then from this V naught equal to 20 by 2. This is equal to 10 volts. Then V naught equal to 10 volts. That is answer. Clear? Next. Can you try what is V naught here? Come on, do it. First you tell me what is this I value. Once you know this I can easily find I naught. Then I equal to 60 by 2 ohms plus 3 ohms and 6 ohms is parallel. 3 in parallel with 6. 60 by 2 plus 3 into 6, 18. 18 by 9, 2. 2 plus 2. This is equal to 15 amperes. I equal to 15 amperes. Now this is equal to 15 amperes. Can you find I naught? Entering current is 15 ampere. These two parallel resistance. Apply the current divider rule. 15 into, if two resistances are present, how to apply current division I told already. 15 into opposite resistance. 6 by 3 plus 6. Then I naught equal to 90 by 9, that is 10 ampere. This I naught is 10 ampere. Once it is a 10 ampere, what is this voltage? 8 into 10, 80 volts. Now this is the 80 volts. But this is minus, this is plus. Means current is driving like this. The current will flow like this. Then this is plus, this is minus. V naught is nothing but voltage across 5 ohm resistor. V naught is nothing but voltage across 5 ohm resistor. What is the voltage across 5 ohm resistor? Voltage divider rule. 80 into 5 by 5 plus 5. These two resistances equally divided. That is 40 volts. But V5 is 40 volts. This is 40 volts. But V naught equal to minus V5. Why? V naught equal to minus V5. Why? This polarity and this polarity is different. That is minus 40 volts is the right answer. V naught equal to minus 40 volts. Any doubt? Simple question. Clear, students? Oh, this is also gate question. Can anybody answer this? I'm giving 30 seconds. Come on, start. Or take 1 minute. Yes, students. Yeah, this is one network. This is one network. Listen. This 5 ohm resistance, voltage across this 5 ohm is 10 volts. This is plus, this is minus, it is given. Wherever the current is entering, that is positive. Then 10 by 5, that equal to 2 amperes. That is the current equal to 2 amperes here. 5 volts, voltage across this resistance is 5 volts. Then positive is given here, current is entering here, 5 by 1. This is equal to 5 amperes. What are the currents entering in this network? 2 ampere entering, 5 ampere entering. Some of the currents entering in the network equal to leaving. Then how much current is leaving? 7 ampere is leaving. Then according to 7 ampere, the 7 ampere current is entering in 15 ohm resistor. 7 ampere current is entering in 15 ohm resistor. According to current direction, this is plus, this is minus. This polarity and this polarity, this polarity and this polarity is opposite. Then what is the voltage across 15 ohm resistance? The voltage across 15 ohm resistor is 15 into 7. But you take negative. Why you take negative? According to current direction, this is plus minus. But given polarities, this is plus, this is minus. That's why minus 105 volts is the right answer. Simple. This is a gate question. Clear? Any doubt? Any doubt, sir? 10 volts given na 5 ohms, 10 by 5, 2 amperes. This is plus is given here na, that's why wherever the current is entering, that's why taken this is the current direction. Current entering in this network is 2 amperes. Next, 5 volts 1 ohm, 5 volts 1 ohm is given. This is positive is given na, that's why current entering is positive. Then this is 1 amp. This is 5 by 1, 5 ampere. How much current is entering? 5 ampere. How much current is entering? 2 ampere. In a particular network, some of the entering currents equal leaving that 7 ampere. 7 ampere is leaving. According to current direction, this is plus, this is minus. But given polarity across 15 ohm is plus minus. But this is minus plus. That's why we take opposite. Minus 105. Next. Can you answer here? You have to find the Vx. If you try to solve by using mesh analysis, it's a lengthy procedure. Simply you can apply KVL, you can easily get the answer. If you try to solve the mesh analysis. But here you have to apply super mesh analysis because source is present between two meshes now. Source is present two meshes. You try to solve by using mesh analysis, but directly I am solving this one just by applying KVL. Just by applying KVL. Yes. What the current here? Can anybody tell what the current? What the voltage across 1 ohm resistor? Vx. It's very simple procedure, sir. Vx by 1. This current is Vx. Vx by 1. Now this current is 2. 2 ampere is entering. Vx current is entering. Sum of the entering currents equal to leaving current. 2 plus Vx is leaving. 2 plus Vx is leaving. This is the current, sir. Vx by 1 now. Vx ampere. This is 2 ampere. This total current is leaving. Now apply KVL. Positive to negative. Take negative. Negative. Current is Vx, volt resistance is 1. 1 into Vx. Positive current is entering here na, positive negative. Positive to negative. Negative. Resistance is 2 ohms. Current is 2 plus Vx. Positive to negative. Negative. Minus 3 Vx. Minus 3 Vx. This is equal to plus 10. Equal to 0. Minus Vx. Minus 4. Minus 2 Vx. Minus 3 Vx. Plus 10 equal to 0. Vx, 3 Vx, 6 Vx. Minus 6 Vx. Plus 6 equal to 0. Then I got Vx equal to 6 by 6. 1 volt. That is answer. Vx equal to 1. If you want to substitute here, if you substitute Vx is 1 volt here, this is 1 ampere. This is current 2 plus Vx. This is 3 ampere. This is 3 ampere, 1 ampere leaving. 2 ampere is leaving. Satisfied. That is Vx equal to 1 volt. Clear? Next. Can you try this? This is a previous game question. All resistors in the circuit shown in figure are ohms each. The switch is initially open. What happens to the lamp's intensity when the switch is closed? Initially switch is open. Initially switch is open. If switch is open, can you calculate R equivalent? Right. If switch is open, try to calculate what is R equivalent. Switch is open condition. Let all the resistances are R equal resistance. This is R ohms, this is R ohms, this is R ohms. If the switch is open condition, the current will flow like this. This is the current direction. Okay. Bridge is balanced now. This product and this product is equal. Bridge is balanced. There is no current through this. And this R ohm is series 2R. This R ohm is series 2R. 2R in parallel with 2R. R equivalent equal to R. If switch is open, R equivalent equal to R. That is the resistance offered for the current equal to R. If switch closed, can anybody tell what is R equivalent? If switch closes, friends. If switch is closed, like this. Even switch is closed, what is R equivalent? Even if you take the switch is closed condition, what is R equivalent? Then also bridge is balanced, then you can get R equivalent equal to R. If you want to check it. Even switch is closed, R equivalent equal to R. If even switch is open, R equivalent equal to R. Clear? Then is there any change in resistance? Is there any change in resistance? If switch is closed, sir, then also R equivalent equal to R. The bridge is balanced. This is R, this is R, this is R, this is R. There is no resistance here. Then RR parallel, RR parallel. 2R, 2R, R. The current will flow like this. This is the path. Clear? Then R equivalent. That is, in both the cases, the R equivalent equal to R means the intensity remains same. There is no change in the intensity. And the switch is closed and the switch is open. In both the cases, R equivalent equal to R. Clear? The resistance remains same. Sorry. That's the reason why intensity is also same. This question based on the capacitances. Can you try this? For the circuit shown in the figure, the capacitance measured between, this also previous question. The capacitance measured between terminals B and Y will be. What is the capacitance measured between B and Y? This one is right. Any answer? Simple. I think electrical students, even in power system, also this type of models. Cables. Okay. Listen, this is the ground potential. This is zero potential. What about this point? This just one wire is connected now. This is zero potential means this is also zero potential. This is zero means this is also zero. That's why I'm drawing this like this. This is CC. And this also CC. These are ground potentials. You have to join these two. This is ground potential. Between this CC. And this is ground potential. This is also ground potential. I'm drawing like this. This is CS. This is CS. Yes, sir. This is ground potential, this is ground potential, and this also ground potential, this also ground potential. I'm drawing like this. This is CC. You have to connect like this. This is CS now. This wire I am bringing like this. This wire, same node now. From same node, this wire I am bringing like this. This is CC. Both are ground. This is which one? CS. This wire I am bringing this side. CC. You have to find between B and Y. This is B. This is Y. This terminals B and Y. Now this is ground. This is ground. These two are parallel. You know that in parallel connection, capacitors are directly added. CC plus CS. These two are parallel. CC plus CS. I am drawing like this. This is CC. This equivalent capacitance is CC plus CS. Grounded. This equivalent capacitance is CC plus CS. This is B. This is B and this is Y. And this is Y. And these two are parallel again. This is ground, this is ground. If two equal capacitors are parallel, this resultant is CC plus CS by 2. CC plus CS by 2. Two equal capacitances are parallel. Then what is C equivalent? C equivalent equal to, these two are parallel now. CC plus CS by 2. This total is parallel to CC. Then plus CC. Parallel combination capacitance directly added. Then from this, what is C equivalent, friends? CC plus CS by 2 plus CC. C equivalent equal to CC plus CS plus 2CC. LCM is 2. Then what is C equivalent? What is C equivalent? CC plus, sorry, CS plus CC plus 2CC, 3CC. 3CC plus CS by 2. 3CC plus CS by 2. Which option is correct? Option C is correct. That is CS plus 3CC by 2 farad. That is the final answer. Very simple. These two are parallel. CC plus CS. These two are parallel. CSC plus CS. And these two again parallel. Parallel connection. Two equal capacitances are parallel by 2. Sorry. Not, this is not. This is parallel. Yeah. Correct. Parallel series. A parallel connection directly added. These two not, sorry. These two are series, not parallel. That is correct. You connect like this. Two are grounded, two are grounded. Not, please correct that one. These two are series. Current is. But you have to find between these two terminals. Series. In series connection, what you can do? By 2. Two equal capacitances are series. C by 2. Exactly opposite to resistance. Exactly opposite to resistance. CC plus CS, CC plus CS is series. And this CC plus CS, C by 2 is in parallel with the CC. Parallel connection directly added. Final answer is this one. But statement you remember, CC plus CS. This current and this current is same. And this total combination is parallel to CC. Parallel to CC. That's why I added that. CC plus CS, CC plus CS. Not parallel. This is series. That's why by 2 I done. So equal capacitances are in series. That is by 2. Please correct it. That statement you correct. Final answer is correct. Whatever I told, this is not parallel. These two are series. And this total combination is parallel to this one. That's why directly add. Capacitance parallel, directly add. That point of view. Clear, friends? Like this you have to proceed. Can you try this? All, this is a previous question. All the resistance in the figure in 1 ohm each, the value of current I is. All are 1 ohm resistance. One method to solve this one is calculate equivalent resistance. Equivalent resistance by, once you know the equivalent resistance, the current equal to 1 volt by R equivalent. That is one method. Or otherwise, simply you can solve like this. Listen, that method you have to solve. These two are parallel, these two are parallel, these two are parallel, these two are parallel, and this combination series, this combination, again these two are parallel, these two are parallel, and these two are parallel, this total combination series, like that you solve. That is one method. I am solving one more method. This is I current. This is I by 2. This is I by 2. Again, this is equal resistance now. I by 4. This is I by 4. Again, this is equal resistance now. I by 8. This is I by 8. Here also same. I by 8. This also. In each branch, you can write like this. I by 8. Any one loop, you have to apply the KVL. I am applying KVL here. KVL you have got. Now, if you apply KVL steps, this is plus minus. All are 1 ohm now. Using KVL, all are 1 ohm. That is minus 1 into I. This is 1 ohm. Minus 1 into I by 2. This is how much? 1 ohm. External loop I am applying for this loop. Minus 1 into I by 4. Minus 1 into I by 8. Minus 1 into I by 8. Negative to positive plus 1 equal to 0. This is minus I by 2, minus I by 4, minus I by 8. Come on, what is the answer? You got it. Plus 1 equal to 0. What is the answer, sir? This is I by 8, not I by 4. Then 1 equal, take I is common. 1 plus 1 by 2 plus 1 by 4 plus 1. I into 8 is LCM. 8 plus 4 plus 2 plus 1 by 1 equal to I into 15 by 8. What is I equal? So this is 1 by I. 1 by I equal to 15 by 8. 1 is 1 volt. 1 volt by I. V by is 15 by 8. That is 15 by 8 is correct. Is that answer? I got 15 by 8. Their answer. Can you check it? Any mistake here? Is it 8 by 15 or 15 by 8? I by 2, I by 8, I by 4, I by 8. That is correct. Is equal to 1. Yeah, you got, you have to calculate I now. Yes, yes, sorry. R, it's not R equivalent. Yeah, that is correct, sir. I equal to, no, sorry, I'm trying for R equivalent. Yes, I'm calculating I. I equal to 8 by 15. And that is correct. Sorry, this is correct, sir. One method is I equal to separately calculate R equivalent. Na? Then you calculate I. Directly you can apply KVL. Then directly I got the I equal to 8 by 15 amperes. Is okay? Yeah, that is option D is the right answer. No need to any doubt here. I equal to 8 by 15. These are the different models of questions. This is enough. Still so many models also there. I will share some questions. Then maximum, if possible, I will solve some more questions tomorrow. Otherwise, I will start the chapter 2. Okay. So this is about the today's session. So there is so many questions are there. You try to solve many questions are there. But once you know the concept, solving of the questions are very easy. Okay. If possible, try to solve tomorrow some other models of questions. Otherwise, start the chapter. Thank you. Any doubt? Yeah. Thank you. I'm ending the session.